Thank you everybody for coming. Hopefully we'll keep this lively after lunch. Thanks for coming all the way down to stage 3. The real purpose of this talk is, last year we came to S4, we gave a workshop to discuss how does Secure by Design, how does the idea of moving security more and more in the lens of the manufacturer, trying to address the security problems that everybody in this room has experienced, how can we move that earlier in the design process? How can we empower security teams to do what they want to do? Well, it's been a big last year. We've ran a bunch of guidance. We've talked to a lot of people. In this talk, what we're really going to try and prioritize is the sticky elements, the things of, we talk about legacy and operational challenges in OT all the time. Let's talk about some different methodologies for actually addressing some of that legacy technology, that infrastructure that's going to drag us down, make us backwards compatible, make it increasingly difficult to build a secure foundation. And let's talk about how we can actually move through some of those challenges. So we're going to be talking about kind of 3 different approaches. One, a much more targeted research and development angle from my own background doing avionics security. We're going to do one that's more human-centered design. How can we better understand the problems to make the security more usable? And another that's on how do we make it so that the perfect isn't the enemy of the good? Where can we target specific security, knowing it may not be perfect, but it's better than what we have? So if you're not familiar with Secure by Design and effort, as an initiative, the TLDR is that as part of the National Cybersecurity Strategy a couple of years ago, we had the challenge of moving the burden of security from those least capable to those most capable. CISA, the Cybersecurity and Infrastructure Security Agency, has really taken up that mandate to try and see how we can empower vendors to do more security on their end to make it so that they can solve the problem once, rather than having that problem be repeated time and time again by all of their customers. It's been a big year for CISA, for Secure by Design. We've released a pledge for IT software developers, software manufacturers. We've had over 250 people sign on, not to solve cybersecurity in a year, but to show tangible, transparent progress to how they are measuring cybersecurity in their products and how they are improving their systems. Be that eliminating default passwords, be that publishing CWEs, not just CVEs, or be that adding logging into their systems. Showing how their customers react to these different security improvements and how they can empower the security team to make some more of these decisions and give them a little nudge over the backfires of sales or maintenance or O&M or support who might have some trouble with some of these new security adjustments, but ultimately better protect their systems. So with that core Secure by Design guidance, the question became, what about operational technology? We've told all these IT companies to sign a pledge. We've written a bunch of guidance for software development. What about operational technology? We've recently released a paper on this called Secure by Demand, Priority Considerations for OT Owners and Operators when Selecting Digital Products. Yes, it is a mouthful. This is what happens when this many people work on a name. You'll notice that we have a lot of countries who have signed on to this, not just the usual cadre, but also some of our European counterparts. And this goes to show that this is not just a US effort, this is really an international effort to try and see, as we see the same security problems time and time again, as we talk about similar problems every year at conferences like this, how can we start helping people to make more tangible progress by empowering security people to do what they want to do already, right? We just need to give them the market incentives, the drivers to make those decisions. So we took the core guidance, we filtered it based off some of the legacy and operational challenges that we all know about in OT, and then prioritize based off of some of the near-term threats, the security gaps that we're seeing on sort of a foundational level, and then how we can support resiliency in the near term as we're thinking about some of the threat picture that has come up recently. And that produced this guidance. Now, there's a lot of pieces of this guidance, but like I said, we're really going to prioritize them. But to give the briefest of overviews, we picked some of these based off of threats we're seeing, like network edge devices being increasingly targeted, really chiseling away at our ability to reliably do segmentation. So making sure that we have logging in place, making sure that we have some authentication capabilities. Some about making sure that your ability to recover is a little bit more refined, things like open standards, making sure that if one vendor fails, well, another vendor might be able to replace that system or do something similar to keep things working. As well as things about to be more resilient, to create more foundational security controls. The focus of this talk is really going to be on 3 things. It's going to say, how can we prioritize Secure by Design as a vendor and an asset owner with things like secure controls, secure communications, and strong authentication? Because fundamentally, the hardest step that we've seen time and time again across sectors of different OT owners is we have a bunch of legacy stuff. It's not great. We all know it's not great, but trying to navigate off of that foundation is, we can't just rip and replace everything. So how do we prioritize the things that make it so that when we buy new components, we aren't propagating, we aren't extending those legacy timeframes, and thus we're not accidentally financially locking ourselves into a system that is increasingly going to be more and more difficult to secure. So we're going to give a couple different methodologies for these, like I was saying before, talking about secure controls. Secure controls, kind of an analog to cyber-informed engineering. How do we take the idea that a malicious actor is going to be operating in your network, and if we're going to connect something digitally, if we're going to automate these systems, how can it be designed with a threat actor in mind? We're going to take that from the example of applying a particular use case and targeted research elements to just improve the security of a given system. Secure communication. We all know that there's been a number of secure communication solutions that have existed in OT, be it DNP3 Secure, SIP Secure, OPC UA, Modbus over TLS. We all know legacy protocols are challenging at the best of times. This isn't kicking the dead horse on legacy protocols talk. This is really going to challenge how can we understand what barriers actually exist for different sectors, for different customers, because while uptake is certainly nowhere near ubiquitous for these protocols, the secure protocols at least do have more uptake in some sectors than others. We can learn the lessons, see how we can improve the usability of security over time. And finally, we're going to be talking about strong authentication. We'll have a little bit of tangent about MFA. Before getting into all of this, I think it's worth commenting on sort of the increasing drivers for interconnectivity and some of the shaky legacy connections that can cause issues. We got a little bit of this in the talk from this morning, talking about future lenses of how if we drive towards increasing smart components, well, maybe we can start burning cities down. But that might not necessarily need to take examples from the far-flung future. We can also look to interconnections of today with real CVEs. So again, I apologize for kicking the dead horse of a legacy protocol, but I'm going to bring up the CAN bus. My background is transportation security. So, CAN bus, 1980s, no authentication, no real security of any kind on this device. It's just a field bus protocol. Jump to 2013, people decided we need to start thinking about tracking emissions. We need to start making these things more efficient. Let's make it so that we digitize more things like the engine control module, build an industry standard with something called J1939. The real ramification here is that previously, if you wanted to hack a car, you had to put it up on stilts or take it out somewhere and reverse engineer it because every manufacturer did slightly different things. All in all, pretty good decision. Makes it so that if you have a truck and you hook a trailer to the back, the brake lights are probably just going to work because it's an open standard. Fast forward a little bit further into the late 2010s, we get things like electronic logging devices in trucks. A safety mechanism to make it so that we can track and make sure that a trucker isn't driving super late into the night hours and then causing some sort of safety incident. On isolation, not a bad idea. What we've seen is that this has created drivers towards interconnectivity, be it cloud, be it MSPs, be it vendor support contracts, or in this very real case from late 2023, this was driven towards, well, if we can get the data from one truck, we can probably get the data from all of our trucks. We can make a fleet management system. Cool, sounds great. Problems with that. There was this CV in particular was basically an MQTT server was hosted on the internet. It was not hosted very securely, and the product then connected back. So now you could send arbitrary commands to the vehicle from anywhere, which is not great when that vehicle is actually 4,000 trucks in a fleet management system. Obviously, like a pretty bad implementation, but you can imagine a world where if we designed some of these systems on less shaky foundations, this wouldn't have even been a problem. These arbitrary commands wouldn't have been an issue. But in reality, if we kind of roll back the examples here, well, that fleet management actually connects directly to the CAN bus, and they don't have to reverse engineer anything because it's an open standard. And so they can actually just look up in a spreadsheet what to do to send all of the trucks the same messages that will make the same attack work across all 4,000 systems. This has thankfully been patched, but this goes to show, like, the more we build on these shaky foundations, the more difficult it is to actually embed the security or start thinking about how these drivers will impact us in the future. So first, we're going to give an example from the secure controls perspective. My background is I used to build detection systems for avionics serial data bus networks. So another example here is a protocol called MIL Standard 1553. It's used in avionics systems around the world. It's used in some nuclear control systems. It's also used in the BART in San Francisco. No flack to the BART. Works well. There's no authentication, and notably there's singular messages that just turn off all of the controllers on the plane for safety reasons. You're not meant to turn them all off at once, but you could. And now if you're thinking about what you can do as a defender to defend this system, the key thing to know is that there's one bus controller that tells everybody else what to do. It's very similar to a Modbus client, Modbus server connection, if you're familiar with that. The bus controller tells everybody what to do. They don't talk unless they're spoken to. The problem is, if you look at the implementation across any number of transceiver developers for this, if you pretend to be the bus controller, it will do whatever you want. And in fact, it will respond, oh, I'm sorry, I must have forgotten that I sent that message. Let me just accept it with no questions asked. Now, again, this is kind of kicking the horse on the legacy protocol issue, but let's step in the foot of the asset owner trying to fix this system after the fact. You could start doing a sort of continuous monitoring-based solution. You can monitor for anomalous timings, normal data in the wrong context, just things that don't really make sense due to physics. But that requires some sort of SOC. It requires a team who can look at all that data. It's going to generate false positives. This requires a whole security apparatus to defend. But if you look at it from more of a secure by design perspective, if we imagine that we assumed a malicious actor was there in the first place, well, in reality, there's only one bus controller ever on this system. By spec, that bus controller tells everybody what to do, so when you designed it, you knew for sure that it was quite an important system. If at the transceiver level, if somebody had just added an if statement that says, is anybody impersonating me? If so, raise an alarm, raise hell, then you could have actually eliminated an entire class of attack, namely like spoofing vulnerabilities and that sort of thing from this field network without going down the long and expensive road of trying to retrofit crypto modules into every single controller on a device. That's an expensive approach, but what we can see here is that you can actually create targeted improvements for the resiliency of the system without trying to rip and replace all of your existing infrastructure. In the future, trying to make your procurements requests, trying to make your design more built around the idea of what if I connect this to something? What if I connect this to an old legacy network? Means that we're going to actually be able to make better decisions in the future and rely less and less on mitigating controls. The next thing I want to focus on is the idea of secure communications. Now, secure comms have existed in various implementations for a really long time, but the uptake is a little all over the place depending on the sector. What I really want to focus on is this idea of human-centered design, bringing in more customer experience, more measures into cybersecurity. This is quite common practice, particularly if you're more on the engineering side or more on the product development side. But this practice hasn't as evolved for many of our cybersecurity colleagues. But the real idea is just trying to understand how does your customer use the product and how would what you want to do interface with that customer's experience. The real concept that we're driving towards here is the idea of a well-lit path. We understand that, S4, we have a lot of technical expertise here. We can imagine any number of reasons for why a secure protocol might not work. Maybe the PKI infrastructure is difficult for an asset owner to maintain. Maybe it's not sustainable and requires increased costs from a managed service provider, and so they elect not to do it and to do some other mitigating control. There's any number of reasons, but we won't know the actual reasons unless you go out, we start interviewing people, and we develop a clear understanding of where the problems are. So CISA is starting to do this for this particular use case. When I'm talking about well-lit paths, I do want to flag an interesting thing for cybersecurity, which is that often the solutions we see for good default behavior are what I would call sort of a negative case. If you imagine with me that you're taking a hike, the easy path is the trail, it wants you to stay on that trail, that's the well-lit path. It's the thing that is easiest for you to do, because going off trail, yeah, you could technically do it, but you probably don't want to. The vast majority of your customers probably won't want to. Instead, how we often see that twisted is things like default MFA practices, which work, but are instead like building up a strenuous hike around the trail rather than carving the trail through the solution. How can we design the solutions such they are encouraging the secure behavior without just making everything else harder to force them into the secure solution? The other example for this is ideas like alerting on bad configurations. If you see something is calling out to the open internet, it was never designed for that particular use case, are there ways to make it so that like a seatbelt chime, though not, hopefully not too annoying, can make it into the environment to make it easier for customers to be secure and to know when they are doing something wrong. Because fundamentally, people might just not know or have the training at different maturity levels to actually understand that they're doing something wrong. Then finally, what I want to touch on is strong authentication. We've seen a number of threat actors in this space, particularly targeting network edge devices, particularly then dumping passwords and then using those passwords as legitimate entry points into the system. Now, of course, in that scenario, passwords in an OT environment, pretty unlikely to change very frequently. And so if you don't have any sort of jump host-based solution with MFA enabled, there's real risk with some of these increasing threats. What I want to flag here is, as we're talking about the idea of perfect not being the enemy of the good, we've seen different sectors actually take the use case of MFA and apply it strategically to targeted components. So rather than saying, I'm going to deploy MFA directly on my controller, I can imagine like an RFID card tapping on the side of a controller if I want to make a change. That probably won't work very well for most environments, particularly distributed environments. But we've seen different sectors, like freight rail, identify key components that are vital for safety, so like a vital signal controller, and say, if you want to change this, you actually need on-prem access, you need to type in a password, and then get some code that you can only generate if you are in physical control of the device. It's a good solution. It might not work everywhere, but there's clear use cases where, from the CISA side, we repeatedly see segmentation, #1 security control we recommend. But if edge devices are being targeted, and on top of that, we clearly see that people really struggle to implement segmentation well, it's probably a good idea to start thinking about where can we apply targeted security controls so that if you're a small water operator or just somebody who doesn't want to spend the time and resources or just wants a backup area of trust, that you can directly apply MFA to a singular component, optionally. So, the real call to action of this talk, as it were, is I've kind of just given a bunch of tiny research examples. But Secure by Design is about creating additional market incentives to help security teams do what they already want to do. If you are trying to make the business case in your organization, particularly as a vendor or an integrator, or even as an asset owner, if you're trying to make the case for spending more money on cybersecurity, there's always going to be the business justification angle. I would encourage you, take Secure by Design, take our parallel efforts, take that guidance, and try to use that to help build out the business case. Prove out, yes, you can spend more resources here to ideally save money in the future, but also to show that there are increasing drivers, there are increasing threats that would help you spend this money and prioritize security that is sticky, that is going to be more expensive to fix after the fact, so that your organization can take a longer-term view. What the actual call to action is I personally have given a lot of transportation-specific examples, because that's my area of expertise. I would ask, as you're thinking about how you can apply ideas like Secure by Design, or where you've applied security before, where have you found success? Where have you found success applying security such that it didn't impede operator workflows, or even embedded itself directly in operator workflows, so it wasn't as frictional as we often think of security? Or where are the areas where you've identified key controllers or key systems that you can embed security in it after the fact and radically improve the resiliency of your system without having to rip and replace all of your existing legacy technology? Those barriers, those success stories are going to be incredibly useful as we're trying to find paths forward and navigating and bridging this gap between where we are now and some sort of Secure by Design feature. So, in conclusion, I'd encourage folks to think about what helps them leap from some of those legacy foundations. Think about some strategic areas for resilience in the meantime. And then for next steps, maybe something like an OT pledge. We'll see. We've had a number of success with our software pledge over the last year. But of course, I'd be keen on hearing feedback from folks here in this audience. And with that, I will open it up for questions. If you'd like, just go down the microphone in the middle, and there's a microphone right there. Okay. So clear and transparent. No questions. All right. Thanks, everybody.